Hello and welcome to Python in 10 lunch break sessions. This is part 3. Today we'll cover lessons 5 and 6. So I'll get started here with sharing my screen. Okay, so last time we split a large data set into equal-sized chunks and then into a subsets based on criteria. Today we'll look at additional ways to pull out specific data. We'll extract 1, a single variable into a new list, 2, a pair of variables into a dictionary, and 3, whole lines into a new file. So to do that, we're going to need a data set, and the one I have curated today is county-level brain cancer incidence rates from the NIH state cancer profiles. So there's all races, males, 50 plus, all stages, and it's a latest 5-year average. And these are age-adjusted incidence rates in cases per 10,000 or 100,000. Now, I have the first 20 entries on the side here. And a big thing here is you see that there's a lot of asterisks because that involves data that is not available because they're suppressed to the low count. So most counties don't have a lot of brain cancer incidence rates, therefore it's suppressed. Now I cleaned this up from a raw CSV file, and you can actually find it at this link here and on or the Python in 10 data set on the Biostats webpage. So that's a bit on the data. So what we're actually going to do here. So we're going to start out by pulling variables to a list. So we want incidence rates into a list. So what we're going to do, you need the data set downloaded, open up Python and start a new file. So over here, I have my new file. We're going to do like we did in earlier ones, looking through data. We're going to have a path. So wherever your path is to your data set, and then your file name. So as an example here, just as a reference, so it's going to be called, I think, county level brain cancer incidence. Again, if you want to get the path, you can open this up, properties, and get the location, or, and then the file name, and you can add those. And again, making sure that your paths have the double, I think, backslashes, and then at the end it should also have a double backslash. So yours will be different than mine because your computer is set up different, but there we go. All right, and then we're going to get variables to a list. So we're going to start out with just an empty list called incidence list, and so set it to these empty square brackets, and then we're going to do our for loop to go through our file. And so this should start to become pretty standard that for everything, we pretty much start with this and then go from there. So inside our for loop, again, line, and this is how we open it, open path plus file, and then it needs to have a set of a colon. And then we're going to do an if else statement. So first of all, we have this thing called if, the string incidence in line. This checks if incidence in the line and then passes if true. So it's just going to skip the first line because that's the column header. So I'm going to open up the CSV file to show you what that looks like so you can kind of understand the reasoning. It's going to take a moment. So here is a CSV file. There's county, state, FIPS, and incidence. So essentially, incidence will only really occur in this first line. I could have really picked any string that only shows up somewhere. County wouldn't have been a good one because county shows up everywhere else, but maybe FIPS, incidence, whatever. But I did incidence as an easy way to show. And this is a very common thing I do if I usually want to skip the column headers. So I'll do an if else statement, if something about the header is in line, just pass over it. Or sometimes I do want to actually use the header, and we'll see that later. So then we'll pass else. So once we get into the meat of this, we'll want to do something. So we want to create an incidence variable by splitting our line. So since this file is a comma separated value, so CSV file, each entry in a row is separated by a comma. So we can split it using the method split, and then we need to designate that we want to split it by comma. And then since we don't want all of them, we just want incidence, we need to designate the index that we want, because indices start at 0, county would be 0, state would be 1, FIPS would be 2, and instance would be 3. So therefore, in brackets after this, we're going to set the brackets as 3. So that will create our variable from that data. And then what we're going to do here is we just want incidence rates. We don't want empty rates. We know that all empty rates are going to have that asterisk. So we're going to check about our incidence variable here. We're going to add final if statement, if incidence. And then here's this special kind of setup here. It means with this exclamation and equal, it means not equal to. So we're going to check if instance is not equal to this, which means there is some sort of data there. We want to append that to our list. And so for each item in the list, we'll create an incidence, check if it's actually data, and then if it is data, we'll add it to our list. And so that is how we do that. And then you can run this. It's not going to show anything up because it's doing add to print, but we can just look at some diagnosis. So let's look at this length of incidence list. Okay, it looks like it has 561 entries. So 561 of the counties had data. And let's just look at the first few entries. So we can go like 0 to 10. This says first, what is it? 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so these are all incidents of brain cancer, but we don't really know what county is because we didn't keep that information. So that's one thing we do, but say we want to do a little bit more, maybe keep values together with some other identifying information, we can actually create variables to a dictionary. So why don't we link county FIPS codes to brain cancer incidence? So we know based on the FIPS code what county had what incidence. So we're going to create now an empty dictionary. So we're going to set it equal to empty curly brackets. Again, do a 4-line, pass over the incidence. And then in the else function, we're going to now create 2 variables. We want a FIPS and an incidence variable. And so what we can do is we can split the 3rd and 4th variable of the lines by commas. So we can do FIPS, comma, incidence, which means, hey, create 2 variables. We're going to split our line, again, by a comma. And then this is a range from indexes 2 and 3. So it kind of looks like it would be like 2, 3, and 4. But how it's set up is it's exclusive, so it's only 2 and 3. And so again, now we have FIPS and instance. We're going to do an if it's not empty, so asterisk, we're going to set our dictionary. So with the FIPS being our key in our dictionary, so unique key, and then our pair being our incidence. And so we can actually see if our county is in the dictionary. I've already run this. So again, let's do length. What's it called? FIPS dictionary. Again, have 561, but now these entries have the county FIPS code. That's a unique code for each county. So let's take a look at if our county is in our dictionary. So we go FIPS dictionary. And so I know that Grand Forks County dictionary, or Grand Forks County FIPS code is 38035. So I'm going to add that in as a string as our key. Let's see if it's entered. Oh, looks like it's not in there. It looks like Grand Forks did not have enough entries to have actual data. But let's look at Fargo, the largest county in North Dakota. And in fact, it does do. So it looks like there's a incidence rate of 18.2. And you can do that with, check any county you wanted. Now, what if we tried a different setup here? What if we want a dictionary that links state names with a list of all county brain cancer incidences, missing or not? So having a dictionary with 50 entries, so one for each state, and then a list of all the county information. So we're going to try doing that. 1 second here. Okay, I am back. Where were we? Oh, right. Yeah, so we want to do this dictionary. So it's going to be pretty straightforward. We're going to create a state dictionary, empty one, 4-line, pass over the instance. Now we want to, in our previous one, we created the 2 different variables using 1 line of code. Now we're going to just split that out to 2 lines. So state line split at index 1 and then instance at index 3. Now what we're going to do here is create an if-else statement that checks if the state is not in the state dictionary, because we look from our slides here, obviously a lot of lines have this will be for a single state. So we don't want to make a new entry for each state. We want to just do it once. So how we can do that is say we can check about our state dictionary. If we can ask if the state is not in the state dictionary, let's create it. So we'll create a new key by state and then create this thing. So you see here, it's not just the index variable, it is actually within brackets. So it's a start of a list with the index as the single entry. So what that lets us do is, if the state is already created, we can go to our else statement, and instead of creating a new key, we can append our key with a the pair being a list. So we can actually append that list with another incidence. So then if we go back to our data here, once we hit Alabama for the first time, it'll create the dictionary key with Alabama and then fill the first instance. But when we get to the second one, it's already created, so we'll just append it with the new another incidence, and so on and so forth. And so when we do that, we can check out our dictionary. So state dictionary. So I think for these ones, if a state has a space, the space is removed. So if I try like this, North Dakota, it's not going to work because the key should be no spaces. So there's North Dakota, and it looks like the only one entry that we saw from earlier, that's going to be Fargo, not Fargo County, but Cass County, where Fargo is. I think I misspoke earlier. We could, of course, do that for anything else, like, for example, South Dakota. And it looks like there's one entry somewhere here. Again, we didn't provide information of exactly what county it is. It was just a summary of the state overall. Okay, well, creating things in Python, lists, dictionaries is great, but often we want to create new files to work on later. So we can get lines to a new file and say we want to do for a single state, but only non-missing instance data. So we're going to create an out file. We did this a little bit last time. We'll create a variable called out file. I'm going to call it out file. Let's see up here, out file. And we're going to open, we're going to have a path and then create whatever name we want. Since I'm going to use Montana, I'm going to do Montana County Brain Cancer Instance, calls a CSV. And then I'm going to need to include W in parentheses, which stands for write. So you can write to a file. When we've used open before, like with the path file, the default is read. So we don't need to have a comma and read, though we could include that if we wanted to. But we need to explicitly denote writing. So we'll kind of do the same format for line and open. Now we're going to do something a little bit different if we have our header, because we want to keep those. So if we have our header, our instance in line, we're going to do out file and the method write, and then just write that whole line. So our new file will have the same setup of county, state, FIPS, etc. So we keep that information. In the else statement, we're going to take all of those rows and put them as their own variable, county, state, FIPS, incidence. These are LCI, UCI is, I think, lower confidence and upper confidence intervals. And then we're going to ask if the state is Montana and incidence is not 0, so only Montana counties with non-missing instance data, we're going to write those to a line. When we're done with that, we'll close our file, and then we'll have that data. And so if I go to my out file here, I called it what? Montana County Brain Cancer Instance. I'll open that up. Hum-de-dum. It looks like, yeah, for this, we have 3 counties, Flathead, Missoula, Yellowstone County, with this information. So that's how we pulled out just specific information. Now, we, through the magic of Python, are not limited to simply doing that. We can also modify data. So we're going to try this again. I'm going to do the same thing, only call this outfile2, call this instance version 2. We're going to do the same thing with the lines. We're going to do incidents and write those out. But then in the other part of it, we're going to start modifying some of this data. So we'll again create variables for all the information in the rows. But then we want to change things. Again, we're only going to look at the ones that have our Montana and incidence data available. First, we're going to create a new variable called county2. We're actually going to strip off a certain part of the string, some of the text using the strip function. If you noticed here in this, all the counties have Flathead and then or Missoula, it has the county. So we actually want to strip that out and also that space. So we're going to strip out all the county to just remain the main name. We're also, what we're going to do here with incidents is it comes as a string, so we're going to turn it into a float. So that's a float is a decimal point number rather than an integer, which would be like a whole number. So we're going to turn it into a decimal number and then divide by 10. So we can actually change incidence 2 is going to be, instead of incidents per 100,000, that was the default, we're going to actually divide by 10. So we more or less have incidents per million. And then we're going to do the same thing with lower and upper confidence intervals to get it per million. So we have all these new variables. We're going to combine them all together in this line here. And you can combine variables. And since this is going to be a comma separated, we want to add commas in between each of the variables. So county2, add a comma in parentheses, state, and all these things. Now, because the incidence and upper and lower confidence intervals were numbers here, we're going to have to turn them back into strings so we can combine these all together. And then at the very end, we're going to write it out, this line 2, and including this thing called a new line character. So actually we'll go in rows, and we'll see more of that in the next talk. And then that'll give us our modified file. And again, I'm gonna just show what line 2 looks like. The last one you can see here now, this is a comma, it's comma separated format, Yellowstone, Montana, these numbers, etc. And when we open that up in our file here, part 2 or version 2, we can see our changes were made to these 3 Montana counties. Let's see, is it going to show up? Okay, so now you see here in the county, they no longer have the county at the end of these, and our incidence, lower and upper confidence intervals are now divided by 10 instead of like 27.1, it's 2.71. So that was an easy way to modify data and add to an out file. Okay, that was lesson 5. We extracted data from files, modified it in different ways, added to lists, dictionaries, and new files. And we saw we can convert between numbers and strings to strings and numbers. And we can even remove things like white space characters or whole types of text. So speaking of white space characters, we're going to jump right into lesson 6, editing data. We will dive more into editing data, including managing white space and the concept of white space, adding, deleting, and changing content. So to get myself ready, I'm going to comment out my code here, and then comment in lesson number 6. Okay. All right, so the data set we'll be using is a FASTA file. So again, more sequence data of 16S rDNA from Archaea. You can get it from, so it's based on 16S, 16 116 sequences from the Silvo database. And they're available at this link here. And just a heads up, this is available as text. So what you're going to need to do if you don't have this yet, you're going to need to download the data set and change it from a text file to a FASTA file. So I'll kind of show how that works in case that's not clear. Let's see, can I copy this? Copy. All right, so where is my tab here? Okay, so here's the data here. So what you can do is save as, and then kind of save it whereas instead of and probably want to just call it probably like what this, and then instead of text you go to all files and then go FASTA, and you just save that wherever. Anyways, but I have that already saved, so I have no need for such things. I'll throw that away or throw it off to the side. Okay, those need to get out of the way here. Okay, so moving along here, you're going to want to, for our goal, we're going to manage white space, so remove and add what's called white space. White space is a term for characters used for spacing in Python. They're actually invisible in a typical document, so in a text or docx or whatever, but they'll show up in Python on important to deal with uncertain situations. The most relevant are the tab and new line white space, so \t or \n, and that really tells Python how to sort of format it into Excel files, into documents, etc. So we've already done that procedure here. Let's open and start a new file. So again, we'll have a path and file variable like we normally do, and my file is halidaptis 16s. It's a FASTA. So we also want a couple out files. I'm going to call it output 1 and output 2. So I want to remove white space, or sorry, I don't actually want to remove, I want to add tab white space. So I want to just show you what this halidaptis file looks like to start with. Let's see here. Open. So looks like here it's a typical FASTA file. It has the header with this greater than symbol, and then all this information, including session, actually a pretty detailed taxonomy, and then the sequence information. So I want to add tab whitespace to sequence lines to format this a little bit. So we're going to create a for loop for our path. So if that greater than symbol is at the line, that means it's a header. So we're going to write that just as normal out to our out file. But if it's anything else, so any of the sequence, we're actually going to write it out with a tab whitespace plus the line. And if I run all this, and then we'll open up and look at our out file to see how that changed. So this is our normal data. If I open up the first one, it'll let me. And we see here, you see how this has changed. Nothing changed with the header, but because we added that tab whitespace, it tabbed it. It indented it essentially with a tab whitespace. So now all the sequences are indented, and it's a little clearer to tell the headers from the sequence. Okay, that is one thing. We can also add a new line whitespace to headers and remove them from sequences. So again, we're going to go through our file. Now what happened is if it's a header, we're going to add a new line whitespace plus the line. Otherwise, if it's a line, we're going to make a variable and essentially modify the line variable to actually strip out new line characters and then write that line to our out file. What that looks like, we'll do here, it's going to be different. See here that in the original one, the sequences after a certain set length, there's a new line character and it came with a new line. And it really, if you make this larger or smaller, it really stays the same. But you see here, these are all running together now. The sequences are all on the same line. It only overruns if once it reaches the end of the window. You can see if we make it bigger, it'll stretch out smaller. So because we removed all those invisible new line white spaces from here, while all making sure we keep new line white space for the headers, so the headers don't run into it. So that can be kind of tricky because you can't see that. And so Python can be really helpful of managing white space. Now, let's move on to adding some content. So what if we want to add content to those headers? Well, we're going to create a new out file called out file 3. And then we're going to create a variable called sample number. This is going to be like a ticker or like a tally. We'll set it to 0. And what we're going to do here is go through our line. If the line is a header, we're going to actually bump up the sample number by 1. So we're going to add by 1. And then this is what we're going to do with this line, which is the header line. We're going to strip the new line white space. We're going to actually strip out that greater than symbol. And then what we're going to do here is create our reformat our line that we're going to have this sample and the greater than symbol. And then we're going to do a string of whatever that sample number is, plus this separator, the semicolon, plus the actual line that we have, which is stripped of the white space in this greater than symbol. And then at the end, we're going to have 16 as sequence and a new line. So all that that's doing here is we're adding information to our header and then making sure the formatting stays the same so that it doesn't run onto further lines. And what that actually has the outcome of doing here is we now have the header. We had sample and then whatever that number was. So we had 116 samples. So it should go from 1 to all the way down to 116. So we incremented this, and then we added more information and clarifying that these are 16S sequences. So that's a way to add not just static information like 16S sequence, but dynamic information of what sample number is in the list. Now, there's a lot going on in those headers. So what if we want to subtract content? Well, we're going to subtract content from the headers and sequences. So create a new out file to do so. And now this is going to be a little more complicated, but I'll try to walk through what we're doing here. And at the end it's kind of cool how it works out. So first of all, we're going to create a thing I'll call seek status. This is going to be a Boolean, so we're going to set to false. So we've looked before doing Boolean operators. They're almost like light switches. So we're going to create a light switch and set to off, to false. We're going to also create a sequence number that's going to be a 0. So like we did earlier here with sample number, we're going to see that this is probably going to tally things and then based on what the tally is, do something. And then we're going to do this sequence subset, which is going to be an empty string. And those will get filled up as we go through the lines. So we're going to do two things. We're going to go through each line. If the line is a header, so it has a greater than symbol, we're going to start doing something. So if the line is a header, if that's true, we're going to have the sequence number be at 0. We're going to, because it's not a sequence yet, we're going to set sequence says to true. And then we're going to split out all the information on that header line into the different setups. So I'm going to just go, no, that's not the right thing. I'm going to go show you that original one to show you what I'm talking about. So it has a session, then it has these different taxa separated by these semicolons. So we're going to call that sequence ID, all the different taxas, and then the final one is the species. So example here is Halidaptis cibarius binomial nomenclature. So we're going to split those out into variables separated by the semicolon. We're going to modify the sequence ID because we don't want the archaea, so we're going to strip that. So it'll just be sort of number. Species, we're going to actually strip out the invisible white space that we can't see on here, but there's an invisible white space that says go to a new line here. We're going to strip that out so that's not messing up our how it's formatted later. And then we're going to write the out file with this new header. So it's going to be simplified. Otherwise, so this is where some of this stuff really comes into play. Otherwise, if it's not a header, it's going to be one of those sequences. We really don't want to do too much with that other than subsetting. So we're going to check if this sequence status is true. If it is true, so essentially if it happened after this was set to true up here, we're going to call our line. We're going to strip new white space so that's not messing us up. And then what we're going to do here is if the length of this sequence subset is less than 200, we're going to add information from the line to that subset. But, and so what that's going to do is it's going to add stuff into it until sequence subset equals or surpasses 200. So that's going to be 200 of those base pairs, ACs, Ts, and Gs. So otherwise, if the length of the subset is 200 or greater, we're going to call something called sequence subset 200. And that's going to be just the first 200 bases. And then we're going to write that out to our new file. And then we're going to switch that sequence status to false to skip any other further sequences until we get to a new header. And what this is going to do is just, instead of giving for each header all the sequences, just the first 200 base pairs. And so that's a way to subtract some content. So let's take a look at what that looks like. So first of all, you can see here that this is a lot smaller. We just kept the session and then the species number in the header. And then we see here for each of these sequences is not the full sequence, it's just the first 200. So going through all that, we really simplified our content here. So what if we want to change more content? So we're going to, so the 16S, it was rDNA, so it actually had U's instead of T's because this was RNA. We want to maybe change it to DNA. Actually, really what we're doing here is back transcribed. And if you really want to really dig into doing this on a more regular basis with like bioinformatics, you definitely want to check out BioPython. It's an add-on for useful genomic data analyses. It does write a function to include this thing called back transcribe, which is actually what we're doing manually here, back transcribing U's into T's. So like we've done many times before, we'll create a new out file, go through our lines. Now we don't really care about the header. So if we see a header, we'll just write it out unchanged. But if we get to a sequence line, we're going to create something called line 2, a new variable, and we're going to replace in the line. We're going to use this replace method. So if every U we find, we're going to replace with a T and then write that new line out and then close our out file. So what this looks like here is, and I'll compare between our regular. So in the regular one, we had U's, but now we see here the only thing that's changed in this new one is now the U's are all T's. And so obviously you wouldn't want to do this manually. And I mean, I suppose you could certainly do this in like a Word document, find and replace. That's really kind of what this is doing here, the manual version of a Word document find and replace function. Okay, and then finally, let's look at another way to change content. Say we want to change headers by shorting the sequence ID, change any spaces into underscores, and changing semicolons into dollar signs. So we'll again create an out file, go through the line. Now we're not going to do anything in the else statement. We're not going to do anything to the sequences, so that'll just be written as normal, but that where all the action is in the header. So first of all, we're going to shorten the sequence ID. We're going to split in the sequence ID two groups, the sequence ID and then the taxa. So it's going to be split by the archaea. So then what's going to happen here is we're going to split. So this is going to go away, but then this first part is going to be our ID, and then the rest is what I'm just calling taxa, the taxonomic information. So with the sequence ID, we're going to create a new variable called sequence ID short, which we're actually going to split by the period symbol, because we can see here that there's several a couple periods here, and we just want to keep this first one. So we'll split it into three, this one, and this one by, or sorry, this one by the period. But then we're just going to keep the first one by having the index of 0. And then we're going to take taxa. We're actually going to replace things. So first we want to replace any spaces with underscores, because sometimes that's helpful. So we see here that in the species, it's going to be binomial. So it's going to have the first genus name and then the species name separated by this space. We want to change this to an underscore in case spaces are trouble later on. And in addition, we saw that obviously these were all separated by these semicolons. We're actually going to replace it with a double $sign. Now, there's times where it's really useful to change one string to another. For example, some procedures only recognize certain syntax. We might want to avoid splitting with a commonly used symbol because it would split incorrect in incorrect places. For example, CSV files are separated by commas. So if you had, say, some titles with or headers or something, or items in a row that had commas in it, you might want to switch all those out with something else so it's not splitting something incorrectly. So we're going to just do that here by having double $signs with the semicolon. Then we're going to write that out. We're going to write out the short ID, double $sign, and the taxa, so that when we pop out the out file here, should be coming. So we see the updates. So we see now this ID is a lot shorter, and then everything is separated by these double $signs. And at the very end, where once this was a space, now this is an underscore. So that's kind of cleaned up there. And that is how we change the content for that file. All right, so just to summarize lesson 6, Python can certainly edit data for a variety of purposes. And white space is especially helpful because you can't see it otherwise. It can be added, deleted, or changed, how lines of data are formatted. And you can, of course, add, subtract, change all sorts of structure in your files and write them to new files. You can avoid, I mean, if you really want to, you can take this survey, but for the most part, that was for the the PDF forms. So with that, I hope this was helpful. Again, we're continuing on with 2 rather than 3 per time. So next week I'll go over lesson 7 and 8, and then I think I'll add on an extra session of 9 and 10 to Python and 10 for this. All right, hopefully that was helpful. Have a great day.